Hi class, this is Mrs. Lyons. Today we're going to be talking about making good measurements. We're going to be talking about specifically volume, temperature, and length measurements, how to do that correctly. We're going to start with reading volume. When we read volume, we're always going to be reading the volume, and when we look at liquids, what we should know, hopefully you've heard this term before, the liquid has like a dip in it when it's in a cylinder. And this dip is called the meniscus, okay? And when you read the volume, you want to read the volume from the bottom of the meniscus. When we read volumes, when we measure volumes, we're going to use graduated cylinders, okay? Do not measure volumes in beakers or flasks. They're not nearly as accurate and precise as we need. So the graduated cylinder has the graduation marks. It has a nice lip for pouring. Some of them even have a plastic guard to keep them from tipping over if they tip over from breaking. So let's look at how we should properly measure. Okay, first thing you need to do to determine the volume in a graduated cylinder is to read at the bottom of the meniscus. The other thing that's important is that you should be looking at that meniscus at eye level. Okay, so if this is our graduated cylinder and the meniscus is here, you should, your eye, you should look at that meniscus. I know, I draw bad, right? This is my great picture of an eye looking at the graduated cylinder. But the point here is that you should get down so that you are eye level with that meniscus. Don't look at it from above. Don't look at it from below. So typically you're going to set that graduated cylinder on the lab bench and then kind of stoop down so you can get an eye-on picture of that meniscus. Okay, we're going to read the volume using all of the certain digits and one uncertain digit. We talked about this in class on Friday. The certain digits are the ones marked on the cylinder, and then the uncertain digit is a guess or an estimate. So let's look at how that's done. If we look at this graduated cylinder, there are two graduations, okay? There are two calibrations. We know with certainty that this liquid is between 50 and 60 milliliters. But then each of these smaller calibrations is 1 milliliter. Okay, so those are 1 milliliter. So we can look and say that not only is our liquid between 50 and 60, we can say with certainty that it's between 52 and 53. Okay, because it's a little bit above the 52. Okay, so our certain digits are going to be 52. Then we have to make an estimate of that uncertain digit. Okay, so now if you look, this picture has that blown up a little bit. So you can see here's the 52, here's the 53, and the liquid is the meniscus, the bottom of the meniscus is slightly below the 53. So we have to estimate how far we think that is. I'm going to say that it's about 0.8, okay, 0.8 of the way between the 2 and the 3. This makes our measurement 52.8 milliliters, would be the correct measurement for you to write down. Okay, so it's really important that you include all of the digits that are certain plus one uncertain digit. If you skip that uncertain digit, you're going to lose points. All right, let's look at this graduated cylinder. Okay, this is a 10 milliliter graduated cylinder. We have the 6 and the 8. That tells us that this line is going to be 7 milliliters. So each of these graduation marks is 0.2. Okay, so we know that our liquid is definitely 6. It's between 6 and 7. And then we can say 6.2, 4, 6.6. And then it's pretty close to the 6.6. I'm going to say 6.62, that 0.2 being the estimated digit for the bottom of this meniscus. Let's do one more. All right, pause the tape. I want you to write down your best guess of this, this measurement. And then I will show you what I got. All right, so what did you get? We can see that this is between 10 and 15. Each of these larger graduations is 1, so this is 10, 11, 12. So I'm going to say that this is 11.5. I'm going to say, it's hard to read the glare a little bit, but I'm going to say it's exactly between 10 and 11, right on that line. So this is 11.5 milliliters. One more. All right, what's the volume here? Again, we know that it's between 50 and 60, so our first digit's going to be 5. Let's see, 51, 2. It's between 52 and 53. So I'm going to say 52 point, and then what is your estimated digit? Is it 8, 9? This is a judgment call. I'm going to say 7. Okay, so, and actually looking at that in the slide now, I would, probably say it's closer to 8 or 9, but when I looked at it initially, it looked a little lower. So that's where that judgment call comes in, and that's why that last digit, as long as you don't put 52.1, is not going to be wrong. All right, one last one. What do you see? Tell me what the measurement is for this graduated cylinder. What'd you get? Definitely 70, 76. Now to me, that looks like that is right on that line. So I'm going to put down 76.0, and the reason that you have to include this 0 is to show that you know with certainty, you're saying that that measurement is right on that graduation line. Okay, there's no, that's your estimated guess, but you know with certainty that it's not a little bit more than 76, it's not a little bit less than 76, it's right on that line. All right, thermometers. Just some real quick information about thermometers. To deter that, we use these to measure temperature. You've probably used thermometers plenty of times before. As with any measurement, we measure all uncertain digits and all certain digits and one uncertain digit. Okay, same thing. Certain digits are determined from those calibration marks, and then the uncertain digit is that estimated digit. Okay, most thermometers that we're going to use will have readings that the tenths place is the uncertain digit. So most of our temperature readings will be something like 0.1 or 0.8. That's the level of accuracy we can get with those tools. Now, a couple of notes just about using a thermometer, and we talked about this when we did the safety lab, but when you're measuring a liquid in the lab, especially if it's a liquid that's being heated or if it's an ice water solution, you want that thermometer in the water. Okay, you want it surrounded by the liquid on all sides. You don't want to put the bulb of that thermometer down on the bottom or side of that flask, because if you do, you'll be taking the temperature of the glass on the flask, and if you've got a hot plate down here, you'll be taking the temperature of the hot plate. So just make sure that you don't touch the thermometer to the glass when you're taking that temperature. So let's do some practice. Same basic concept when we're measuring. Okay, so we're between 80 and 90. Our first digit's going to be 8. We've got 81, 82, 83, 84, 85, 86, 87. So our measurement's somewhere between 87 and 88. And then that last digit is our estimate. So what do you say? 0.6, 0.4. Okay? Sometimes when I see these, I do them differently. 0.4 was my estimate. If yours was a little bit off, that's fine because it's an estimate digit. It's not precise. Look at this one. Let's see. We are between 30 and 40. 31, 2, 3, 4, 35. So I'm going to say my first two digits are 35. Do you think it's right on that line, or is it 35.1? Those would be the two answers I would think we would come up with. I said that it's right on the line, so 35.0. One more, and then we will be done. What is the length of the wooden stick? So we're using a centimeter ruler. We know it's between 4 and 5 centimeters. We've got 0.1, 2, 3, 4, 4.5, somewhere between 4.5 and 4.6. How many digits can we have? Is it enough to say that it's 4.5 centimeters? Absolutely not. We need that estimated digit. Okay? Now, can we possibly estimate 2 digits? No, we can't. We can only estimate 1 digit. So that wooden stick is 4.54 centimeters in length. Okay, we will be doing a lab where we are measuring the volumes and masses of some substances and then calculating densities. Until then, I will see you in class.